Hello everyone, my name is Alexander Zelenin. Today we have a guest, another software engineer. So I hope today it will be funnier. Tell your name, please.
Hi, my name is Oleg.
So today we will solve just a random medium problem from Hackerrank. I will not read all the condition, I will just explain it by myself. So we have a string with some text, and we will need to encrypt this text with some algorithm that we will need to write. We will calculate the amount of symbols, length of text, and we will have some kind of table with row and columns. The amount of rows will be higher or equal to the root of length of this text and like math floor of root. So for example, if we have 54, we will have 7 rows. So 1, 2, 3, 4, 5, 6, 7. 7 rows. And count of columns will be greater or equal to this number and less or equal to the math tail of the root of the length of the text. So in this case, it will be 8. So it should be like lower number that possible to fit all the text. And this text is without the spaces. So we remove all the spaces, we put the text in this table, and then we will go by like vertical lines. So we will took like every first letter from this table and add the space after this. And then we go for the next, and so on. So from this text at the end, we have example. For example, if we have text, have a nice day, output will be next one. Explanation is next. We have 12 letters. Square of 12 will be 3 and something. So it will be between 3 and 4. We have 3 rows and 4 columns. We write text we have in these rows and then just go for vertical lines and split it with spaces.
Yeah, makes sense. And we just read off the vertical lines and we got our output.
Okay. How you think we can solve this problem?
What's the maximum length of the text? Is this a
Yes, there is constraint. Looks like it's just 81 symbol.
oh, well then maybe we can just do it exactly like they say. We put it in a matrix, a two-dimensional array, and just go off one column at a time.
Yep, it's possible to do this. Maybe you can tell me what will be space complexity and time complexity of this, or I can explain what is this and how to calculate this if you want.
So I do know those. Let me think of the code though. So initially we have to go through the whole string to put it in the array. So the space complexity will be just n because we're just storing everything in one array.
Yep.
And then the time complexity, so that'll be n plus. Then we have to go through the array itself. So that would be 2n. So that could be reduced to n, right?
Yes. So it's possible to create a matrix and so on, but maybe we can do it with like one cycle just for fun, just
Mm.
to increase the difficulty
The
of this
challenge,
task.
yeah,
Yes.
yeah. That's a good point. Well, let's see. So we'd have to jump. So we'd have to first calculate the number of columns, and then just jump. We have one counter, which is our starting index, and then the other counter is which is our current index. So let's say our starting is 0 plus the length of columns and etc. until we reach to the end. But then there's a space there. So wait, can you scroll down a bit?
I think you can scroll by yourself on the screen.
Oh yeah, let's see. Oh yeah, I can. Um, a and yeah. So we just iterate the start with the starting pointer plus 8 or whatever the column width is, and spit out the letter, and then go back to the starting pointer, increment the starting pointer by 1, and jump the next the current pointer over. You basically use two. You know what I'm saying? Use two pointers.
You can use 2 pointers if you want. Why not? Or
Yeah.
what? Yeah.
So what I'm saying is, pointer 1 is just going to be our start index. Pointer 2 is going to be where we're at right now. So we're going to go, from 0 to, let's say on the have a nice day part, we're going to go from 0 to 4 to 8, and that's HAE. Then we're going to put out a space. Then we're going to go back to the first pointer and increment it by 1. So now we're going to go from 1 plus 4 is 5, right?
Okay, but what if our text will be like this and it not divided directly to some number, since we have some spaces?
Then when we reach the end of the array, we just know that we're done. So if we increment it too far past the length, then we know that it's to just make a space and go back.
I mean, in this case, we have the
Oh, there's spaces. I see.
yes.
Oh, okay. Interesting, huh? So then maybe we need an offset. So, hmm. So would time complexity of one count if how is this output uh I see, okay.
We can start with your original idea and then go to optimize it somehow, because the main thing is to solve task. It not not It's important to do it in optimal way, but the main thing is to solve task in time. So we can
Right.
start with this and try to optimize it later.
Okay, let's do that.
Okay. So we have some prepared code is by the platform, and we need to complete only the function itself. Since we have input like of text, and it's only text. Okay. But anyway, we have this function, and we receive one argument, which is s, our string, and we need to return new string, so encoded one. So let me just create a string and just return it. So maybe you can write what is between of this. We will use JavaScript
Okay.
here. I will help you with JavaScript if it will be required.
Yeah, so yeah, it's been a little while since I've done much JavaScript. So let's see. Let matrix equals this. And then let's see. We need column equals. We need to figure that out.
Yep.
So, and then and just for readability, so let square root equals what is it? Math dot square
Yes.
root. Yeah.
Yep.
Of is it
Uh,
s dot length or
yes. S dot length.
there we go.
You remember everything.
Yeah, it comes back. So then we've got math dot. Was the columns floored or was the?
Let's take a look. For the column, it will be sail, and for the row is floor.
Okay.
But it maximum sail. It's like not guaranteed that it's sail. We will need
What?
to,
Oh,
yes. So it's like maximum value, because it will be from the floor to the sail. And the row itself also will be from the floor to the sail, since, let me scroll here again. So we have floor of root, and our row count is greater or equal to the floor, lower or equal to column, and lower or equal to sail. So it
so if
can
we
be.
have 64. Oh, we need a first. Oh, wait a second. And we don't. Hold on. This is more complicated because those spaces. We don't know the length of the string until we remove the spaces, and we can't remove the spaces until we iterate the string. Now, if we don't care about doing, 2n versus 3n versus n, right? Then that's easy enough. We could just first remove the spaces and then start the matrix, right?
But initially, by the conditions, we have L is length of the text, right? So our row column will be anyway minimum of the floor. So
But no, because it says after removing spaces is 54 characters long. So first the spaces are removed from the text. Let L be the length of this text. Well, let's see if their example code removes the spaces.
yeah, you're right. There is, yes, you're right.
So we need to first iterate the array, remove the spaces, then.
I think we can just count them instead of removing.
But it's still we might as well remove them because in order to put them into rows and columns, we might as well stick them in, right?
Okay.
Well, yeah, okay. So if we, yeah, I'm sure there's a more efficient way to do this, but just to solve this problem, we could just do that.
Okay.
And there's JavaScript has a string replace function, right?
Yes, it has, but originally modifying strings in JavaScript is not efficient because strings is immutable at all. So anytime you modify string, JavaScript create a new string. But that's fine. That's fine for like our task.
Yeah. So in this case, we just do a s equals s replace
Yep.
spaces,
Yep.
right?
Please. Yep.
That works, right?
Yes. It should work.
There we go.
But still, the row count possible to be sail, and the column is possible to be floor. We will need to count it accordingly to put all the put everything in our matrix.
But we know that rows are.
We can start with this. We can then test our code and see how it will works with just sail and floor. Maybe it will works, maybe not. We'll see. Okay.
Okay. Yeah.
Yep.
Yeah, that's ambiguous there. Okay. So okay, you've got to remind me. Is it s dot each, or how do you
What?
iterate this?
I think we can just iterate with just for. So like
Yeah.
from zero, from I equals 0 to I less than column number, row number, right?
Yeah.
And inside, maybe you want to go through, like through what?
Well, I was just thinking of having a pointer for the row and the column, and just iterating from I equals 0 to length of string.
Okay, you can do it as you want, as you are comfortable.
Well, I'm open to suggestions.
No, we can go through the string. It's fine. So it will be so since it's strings doesn't have this iteration, but let me just write a simple iteration over the string. So while I is less than s length, I plus equal 1. So and not the symbol, it's bad name. Char will be si.
Hmm.
So we have charged and we have index in our string.
And I was thinking something like
Okay, and current column, or you don't need this one?
you're right, current column. We do need current column. But you know what? I want to do it your way just for fun because that's probably going to be cleaner. Less than. So maybe I'll just call this current row.
Use camel case. It's usually a camel case in JavaScript for
Ah,
variables and
okay.
other things.
Yep. I'll just say row. Equals 0. A row less than rows. And
Okay.
then now I'm thinking we'd have to do a bit of multiplication there, but that's okay. So
Yeah, for now it's fine. We will optimize like on next step. And I presume we will not optimize so much, so we will end up with the same complexity you told at the start. I'm not
okay,
sure that we can go beyond this anyway. I mean, we can optimize it to be like 2 times efficiently than we're writing right now, but in meaning of complexity, nothing.
okay. So let's see. So can we do let I equals and so the index in the string would be the row times calls plus call, right?
Yeah, looks like.
And then if I greater than s length, then we return or break. Can we break two here?
Yes. You want to break both of? No, you want to break. 1 second. Why you want to break? If there is no symbols, right?
Yeah, because the last row might not have enough, you know, filled in.
1 second. It possible somehow to break through two cycles, but I exactly doesn't remember how to do this. It's possible to write additional condition like in outer array, but I think you can just do
So
like
I just
this
looked it
and
up. I just Googled it and I found the answer. There's actually there's a label function.
yes, but it's not a good idea. It's like a go-to, so
Yeah,
it's not the best practice that possible to
I
use.
see. I see. Okay. Okay.
Usually, if you go in such problem, it's better to rewrite your code to use some external function or whatever to do like this. Uh, let's do like this. If our I is less than our length, we do some code here. Otherwise, we do nothing, and it will just iterate a few more times, and that's all.
Okay.
We will
Okay.
optimize this part later, because I think it's possible to do with like one cycle and so on. So let's
Okay.
do it
Okay.
later.
All right. So so let car equals s I.
Let's call it not I, but maybe index or something like this, because we already have S, and better to like rename it at least a
All
bit
right.
for more
Right. Right.
readability. Yeah.
Yeah. I see what you're saying. Okay. So and then so matrix, and we're gonna do the row. Oops. Come back here. Equals. How did you do that? I watched some of your videos. Let's see. You did matrix row or.
Originally, sorry. In this case, you can create it here, since you're
Oh, right. Of
starting new
course.
row and you can like create it always.
Right. Of course. Of course.
You don't
So
need
then.
default value, sorry, like this.
Oh, of course.
Like,
Yeah. 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 No. Okay. Yeah. And then. And I guess here as well. No,
um,
no. Of course, we do need to here. Never
oh,
mind. Equals car. All right. You gotta remember here. Here it's late at night, so you're fresh.
yeah.
Already
Also,
typed.
I think instead of mentioning the column itself, you can just push an array. What you think? Like,
I'd
push.
like to mention the column only because it's explicit, but
Okay,
that's all.
okay. Yeah, we
You
can
know.
we can do it like this. Why not?
Yeah. All
So
right.
okay,
Cool. And then
looks
we'll
like
have
we
to
please.
say again.
We create our matrix, so we can like go for next step, which is good.
Okay.
So now we can iterate over our matrix and find what we need to do. The one thing that I want to mention before we go to next step, can I just scroll a bit up? That
Oh, the
the
spaces.
length,
No, no,
yes,
we got the spaces.
in the end, yes, first of all, we will need to add the spaces. And second thing, in the end, we have lesser um, string length, since the last row can be like less than full.
Yeah.
Yep, please.
Then we can just copy some code.
Yep.
Now here is if. Okay, so we need to get that. So I'm just gonna without the any conditions, just for orienting myself. So let car equals 1 second. Okay, sorry about that. Okay, is matrix, and we're gonna have,
It will be same, row and col.
yeah.
Yep.
All right, so then, of course, in this case, if matrix row, there we go. If
You can check with the char itself.
okay, and what is it by default? Null or undefined or what?
It will be undefined. You can just write if char. You cannot compare it. Just if char. That's all. That's enough.
So in this case, we're not going to have a char 0. Yeah, that won't be a problem. So,
If char will be 0, it's still a string, and it's not a
right,
problem.
cool. So
Only empty string will not work in this case.
then we've got encoded. What is it? Append or plus equals or what?
Plus equal.
Now, is it just like in Python? Is it more efficient to have a list and then join them together later, or in this case?
Yes, right now it's more efficient, but not so much. It's like 50% efficient in Firefox and about 20% efficient in Chrome. But it's not such an efficiency, so the current solution is fine for now.
Okay, great. So now this looks right to me. Do you see anything I missed?
Yes, spaces.
We've gotten rid of the spaces up here.
Yes, but we need to add spaces in the last one. In the encoded
Really?
message, yes, we need to have spaces after
Oh, yes,
every
yes.
column.
Yes, thank you. So then after every column,
I think you can add it just to encoded message, like here.
yeah.
I'm not sure what about the last symbol. Do we need to add space after the last symbol? No.
No.
So we just need to remove one last symbol here and it will be fine.
Well, we could also do the if statement, because what if it's an empty string? We should be able to support empty strings.
Sorry?
So if we need to be able to support empty strings.
I think let's 1 second. Do we need to do this? Because the minimum length of string is one symbol.
Yeah.
So looks fine.
Yeah, okay. So how do you remove one from a string?
We can just do like encoded equal I remember how to do this with array, but with strings
Is it substr? Yeah, substr.
Yeah, you're right. Substr. Please,
I'm just Googling it.
Please,
If
when
that's
you're
something I remember.
clicking, you move my screen also.
Oh, sorry.
Yes, so from 0 to encoded length minus 1. Yeah. But right now we will have one problem. The problem will be next. I will just explain for the small strings. If we have 1, the root of 1, the floor of root of 1 will be less than will be 0. So we will have we'll have 0 rows in this case.
Good point. Yeah, I didn't think of that.
But let's run our code and see. I presume that at least some of cases, yes, some of cases solve it properly, 2 of them, And we have a third case, chill out. Our output is this one, and expected was this one. So we miss some symbols. And
Yeah, so
I
the square root
presume...
of 8 is between 2 and 3.
Let's take a
So
look just for a test. So like for sale. Yes. So I just increase the size of the matrix for now, but I presume if we will run all the cases, sorry, if we will run all the cases, not all of...
interesting. I think they were thinking something else when they wrote the problem.
Okay. Okay, but
Oh, it's okay.
okay.
It's a poorly written problem, but that's all right.
Yep. Okay. So in the end, let's just write down space complexity and time complexity to ensure that we are on the point. So space complexity and time complexity. Okay.
So space complexity is n, right?
Let's go through our code and see what we have, like where exactly this space
Oh,
complexity is stored. So
right, because we
first,
have the matrix and the encoded.
yes, so first of all, we have the encoded, which will be exactly, it can be, and it can have more length than original string if original string doesn't have spaces and encoded have them, right? But it will be not too much higher, so it will be still O as length. Okay, how they call this letter? L? Let's use L.
Okay.
So OL. For the matrix, we'll also have amount of symbols equal amount to like cells of this two-dimensional array equal to the our string without spaces. So it will be maximum again OL, right? And we doesn't have any other variables here that do something else. Also, one thing that I want to do is to change let to const, since this variable is doesn't changes. So also here, since we assign them just once, we can use const just to be sure that they are not rewritten somewhere, because it's easy to rewrite such thing in cycle when you have rows, and so on. So for space complexity, we will have like 2L, we drop constants, and we have OL. Everything is fine. For the time complexity, first of all, we have string replace operation, which take up to OL, right? Since we need to go through all the symbols and remove. Originally, it will be higher than OL, but I'm not sure how it works like underneath JavaScript. Since if we will do it manually and we will rewrite the strings itself, since they are immutable, we will create like a new strings, and it depends how many spaces we have. And like in worst case, we will, for example, if every second symbol will be a space, so we will create like, so it will be like n square.
Wait,
Something like this.
I don't get that part, because all we have to do is iterate through the first string and
Yes.
append everything that's not spaces to the second string.
Yes, but a thing that I had told you before, that in JavaScript, strings are immutable. So if you have
Oh, yes, I see. Yes, because
string
you have to
like,
create a new string.
like this one, and we iterate through this, it will, to remove this space, it will create first a string like this one. So it will be like a new string. Then it will create new string and so on, and only then remove the old ones. There is a lot of different optimizations in the current browsers and so on, and one of interested one currently in Chrome, which can lead to memory leak, and very big memory leak. Originally, they instead of copying text itself, they copy pointer to the part of the text of original string. So it sounds a bit complicated. I just share some interesting things. It's very efficient, but it can lead to a really big memory leaks. For example, if we have some text which is, for example, 1 megabyte length, and we do something like text substring from, for example, don't know, from 100 symbol for 100 symbol. So we presume that we store only 100 symbols, but originally this 1 megabyte doesn't go anywhere, so it will be still on the memory until we remove both of them. Since this text will have pointer to this one. But it's micro optimization, we doesn't need to think about them for now. So let's return to our time complexity. For this, it will be 1. Everything is fine. Here we have 2 cycles, one inside the other one. But generally, both of them combined will be not greater than OL, right? Like by our definition, since they like.
Well, especially if we break at the right moment.
They will be. They can be slightly greater exactly than our length, but it will be just slightly greater, since we make a sale for both of them. And inside we have just assign variable, so it's O1, and for the next iteration it will be like the same, so OL. But again, this operation is not so cheap as a lot of people thinking, since instead of modifying string itself, we're creating like a new strings every time. So originally, this string itself can take up to like OL. So here we will have like this one. But in like we doesn't have a lot of options here. We can go with another array and then make a join, and it sounds reasonable to do it like this if we want to like make optimal way, but we will consider that this is O1, but generally it's not O1 in the JavaScript, because that's like our language limitations. So, and to remove the last string, it's again will be OL in the JavaScript, but in most of normal languages it will be like 1. So we end up with OL for time complexity, and that looks good enough. Since I presume we will not able to go less than OL for space complexity, since we anyway need to create encoded string, and it will be by itself, it will be already OL. And for time complexity, we need to go through all the symbols at least once. So it again will be at least OL. So in meaning of algorithm complexity, we cannot optimize it. But maybe we can optimize like some micro things, but it will be not today. So we solve a task. We got like higher score, 30 points for this one. Thank you, Alec, for today, for joining me.
Yeah, well, thank you.
Have a nice day.
Yeah, you too. Bye.
Bye.